Welcome to this explainer on cloud-native observability. Look, if you architect or operate modern cloud platforms, you already know the massive operational complexity we are dealing with today. We're not managing simple monoliths anymore, right? Our applications operate across this tangled web of Kubernetes clusters, cloud-native services, distributed systems, APIs, hybrid environments, you name it. And it's all stitched together by automated pipelines. And as organizations scale these sprawling environments, getting deep operational visibility isn't just nice to have, it is a non-negotiable requirement. Without it, even the most beautifully designed cloud platforms become pretty much impossible to operate reliably at scale. So today, we're going to dive into why observability has officially become the foundational backbone of modern cloud operations.
So here's our roadmap for moving from basic monitoring to deep operational visibility. 1. The limits of traditional monitoring. 2. The pillars of true observability. 3. Taming dynamic Kubernetes. 4. SRE and fast feedback. And finally, 5. Enterprise standardization.
All right, Section 1, Limits of Traditional Monitoring. In the past, traditional monitoring was really just focused on static infrastructure metrics. We're talking CPU, memory, server availability, network health. Basically, if the box was up and you could ping it, you were golden. But man, the cloud-native reality is an entirely different beast. Now we're dealing with microservices, asynchronous APIs, and highly dynamic, ephemeral infrastructure. A static server check is literally useless when the infrastructure is constantly shifting underneath your applications.
And to see why, just think about the anatomy of a distributed incident. Cloud-native systems mean incidents almost never happen in isolation. A single production issue in the real world? Well, it might look like networking latency, container failures, API dependencies acting up, storage performance tanking, authentication systems timing out, and Kubernetes scheduling errors, all hitting at the exact same time. Rapidly firing alerts just absolutely overwhelm the engineers. Without the right tools, debugging a cascading failure like that is basically impossible.
Moving on to Section 2, Pillars of True Observability.
Observability has to extend way beyond simple, high-level dashboards. Organizations now desperately need deep visibility into how systems behave internally. Because at its core, observability is fundamentally about understanding exactly why systems act the way they do. It's the difference between a dashboard flashing red just to tell you something is broken and a system handing you the precise diagnostic context to figure out the exact root cause of that failure in real time.
Modern observability platforms give you this visibility through core telemetry signals. We've got metrics for high-level workload performance, logs for digging into those granular operational bottlenecks, traces to actually track requests across distributed services so you can pinpoint root causes, and dependency mapping to visualize that complex architecture. Brought together, these signals form a true enterprise telemetry platform. They allow engineering teams to finally make sense of system behavior across a massive scale.
So the fundamental architectural truth here is this. The goal is not detecting failures. It is understanding exactly why systems behave the way they do. Detecting a failure is really just the starting line. Observability gives you the diagnostic map to actually reach incident resolution. Okay, Section 3, Taming Dynamic Kubernetes Environments.
We all know Kubernetes isn't just about deploying containers. It is the operational foundation of modern cloud platforms. But achieving operational excellence at scale, that requires way more than just orchestration. As you build out reliable platforms, Kubernetes success absolutely demands strong governance, security integration, and crucially, deep observability maturity.
Which leads us to a pretty critical question. How do you troubleshoot infrastructure that is constantly changing and honestly might not even exist anymore by the time you start looking for the problem? Kubernetes environments are insanely dynamic. Containerized workloads are ephemeral, pods scale up and down automatically, services move across nodes in milliseconds. The old-school approach of SSHing into a server to read a log file? Yeah, that is completely dead here. To handle this kind of ephemeral infrastructure, organizations have to use centralized platforms with some very specific capabilities. You need workload tracing, cluster visibility, distributed logging, real-time telemetry, and automated service dependency tracking. If a pod kills, spins up, fails again, and is destroyed in under a minute, your telemetry platform must capture all those signals in real time. It has to map the dependencies so you can analyze the ghost of that workload long after it's gone. That is how you handle dynamic architectural patterns.
Let's look at Section 4, SRE and Incident Response.
Site reliability engineering heavily depends on observability to create these incredibly fast feedback loops. Step 1. Identify incidents proactively.
Step 2, understand root causes immediately using distributed traces. Step 3, reduce downtime, your mean time to recovery, by applying targeted fixes instead of just guessing. And Step 4, optimize overall performance. Basically, the faster you understand system behavior through telemetry, the faster you recover from production outages.
And this highlights the massive cultural shift observability brings to the table. On the one hand, you have operational friction, high uncertainty, slow debugging, and fragmented visibility. That stuff completely kills engineering velocity. But on the other hand, you have a superior developer experience, identifying issues faster, efficient debugging, and optimized deployments. Strong observability removes operational uncertainty. When engineers aren't terrified to hit deploy because they have real-time visibility into their code, innovation and deployment frequency speed up dramatically.
Finally, Section 5, Standardizing Enterprise Telemetry. As these environments scale up, observability itself has to be standardized. Without standardization, your operational visibility becomes totally fragmented across teams, which just creates massive troubleshooting complexity. Imagine Team A using one proprietary tool for logs, Team B is using open-source metrics, and Team C is flying completely blind with zero tracing. When an incident crosses all three of those services, it is a total disaster. Fragmenting your telemetry is a severe architectural anti-pattern.
So, to maintain operational maturity, platform engineering teams have to standardize exactly how telemetry is handled. You need enterprise-wide targets, consistent logging formats, telemetry collection, unified alerting strategies, standardized dashboard visibility, and universal tracing standards, very often leveraging frameworks like OpenTelemetry. Standardizing across the enterprise ensures that when an SRE looks at a trace, it tells a complete end-to-end story, no matter which team wrote the underlying microservice.
This brings us to a really powerful core takeaway. Reliable platforms are built on strong operational visibility. You can have the absolute best code, the most brilliant microservice architecture, and the most advanced Kubernetes deployment in the world. But if you cannot see what it's doing, you cannot run it reliably at scale. Metrics, logs, traces, and centralized telemetry are the non-negotiable foundations of cloud-native reliability.
So, I'm going to leave you with this final provocative question to think about regarding your own organization's operational maturity. Does your enterprise actually have true observability, or are you just monitoring what's already broken? Really think about your team's feedback loops, your ability to trace distributed requests, and your overall Kubernetes visibility. The answer to that might dictate just how reliable your cloud platform truly is. Thanks for joining me for this explainer, and keep building reliable systems.